In this video, we're going to talk about converting from Cartesian coordinates to polar coordinates. All right, and so once again, just like in the conversion from polar to Cartesian, this little diagram here is useful in telling you the relationships that you need to convert. Okay, so we are given Cartesian coordinate systems in this conversion, x, so we know what x and y are, and we want to find what r and theta are. And so here you can see the two equations that we're going to use to do that. Okay, so the first one, r squared equals x squared plus y squared, that one just comes from the fact that I have this little triangle here. And also in a previous video I explained about the relationship between Cartesian and polar coordinates, and that's where this diagram comes from. So if you haven't seen that previous video, you might want to check that out. So we have this triangle here, and it's a right triangle, and so we know from the Pythagorean theorem that x squared plus y squared is going to be equal to r squared. So that's just where this first equation comes from. All right, and next up we have tan theta equals y over x, and that just comes from a little triangle trig here. Again, we have a right triangle, so theta, right, is this angle right here. And for theta, y is the opposite and x would be the adjacent side. And so we know that the tangent of theta would be equal to y over x. And that's where those two formulas come from. So unlike the case from converting from polar to Cartesian, when you're converting from Cartesian to polar, there are infinitely many possible correct answers. All right, and so that's going to come from the fact, and you might have noticed that these two equations are not solved for r and theta, right? So there are going to be some choices that you're going to have to make. When you solve for r in this equation, you're going to get r equals plus or minus the square root of x squared plus y squared. So that's a choice that you'll have to make. Should I take the positive value for r, or should I take the negative value for r? And we'll talk about how to do that in a later video. Same thing over here with tan theta equals y over x, right? There are infinitely many solutions to that equation given y and x, right? So once again, you will have to choose, hey, which value for theta should I use based on this equation here? And the way that you're going to do that, right, is that you are going to have to know what quadrant your point lies in, okay? Does it lie in the first quadrant, second quadrant, third quadrant, or fourth quadrant? So whenever you are making these conversions from Cartesian to polar coordinates, you're always going to have to keep in mind where your point is located, and that's going to guide you. Okay. In the examples that follow this, I'm going to be using this unit circle here, and this is pretty much a standard unit circle, with the exception that what I did was I went ahead and I calculated out these values here for tangent, and I listed them beside the point. Okay, so if you remember back to unit circle trig, right, the tangent is going to be the y coordinate divided by the x coordinate. So this would be 0 divided by 1, which is 0. Okay, this one up here, square root 2 divided by square root 2, is going to be a positive 1. And so for some of the others, oops. For some of the other coordinates, it might be a little bit confusing, so let me talk about those pretty quickly. So for this one right here, the tangent, right, would be 1/2 over square root 3 over 2. Okay, and so if I divide two fractions, I invert the one I'm dividing by and multiply. And these twos cancel each other out. So I get 1 over square root 3. So you might encounter that value sometimes, 1 over square root 3. If you do, right, then you might not recognize that that's equal to square root 3 over 3. So if you rationalize this 1 over square root 3, multiply top and bottom by square root 3 over 3, I get square root 3 on the bottom. Square root 3 times square root 3 is positive 3. So that's where this value comes from. And likewise, if I calculated this value, square root 3 over 2 over 1/2, and reduce that as much as possible, I get square root 3. So these are some of the values for tangent that are going to come up in these problems here. Okay, you can see, like, if the tangent comes up to be 1, right, then there are a couple of choices, pi over 4 over here, and there's also a tangent of 1 down here for 5 pi over 4. Okay, so which one you choose is going to be where is your point located. If the point that you're trying to convert is located in quadrant 1, you're going to choose pi over 4, right? If the point that you're trying to convert is located in quadrant 3, right, you're probably going to choose 5 pi over 4 over here. So always when you're making these conversions from Cartesian to polar, you're going to want to keep in mind what quadrant that your point lies in. There's a couple of, there's one that I didn't talk about so far, and that's this value for tangent for pi over 2 and 3 pi over 2. Again, if you try to calculate the tangent of pi over 2, that would be the y coordinate over the x coordinate, right? And that is undefined because you're dividing by 0, okay? So, and you can also see there's a situation like that down at the bottom here where it's undefined, okay? So you could run across that when you're trying to convert from Cartesian to polar. If you get a tangent that's undefined, well, then you would know, that the value is either pi over 2 or 3 pi over 2, okay? And how do you determine which one? Well, where's your point located? If it's up here on the positive part of the y-axis, then you could probably go with pi over 2, right? And down here with 3 pi over 2 if it was on the negative part of the y-axis. I remember one of the weird things about converting to polar is that there are infinitely many correct answers here, okay? So sometimes we're going to put restrictions on the problems, and we are going to make it so, use those restrictions to make it so that it is it gives a unique answer. And so an example of what that might look like is here, and this is the example that we'll do next. It says find the polar coordinates of a point with Cartesian coordinates minus 7 square root 2 over 2 minus 7 halves, where r is greater than 0 and theta is in between 0 and 2 pi. Okay, so so here this tells you, hey, you're going to pick the positive value for r, and here you want a theta between 0 and 2 pi. So that will give you a unique value if you impose these additional restrictions on there. One last thing is that if you get a value for the tangent that is not on one of these that's listed on the standard unit circle, right, then you would have to most likely have to use your calculator to figure out what the value is. But we'll go over that in a later video.